Alrighty, so we're going to go ahead and work on problem 2 for group 3, and first we're going to open up static structural. We are going to have to click into our engineering materials here and type in Douglas fir. Then with Douglas fir selected, we're going to click down here, add a density, and here we're going to type in 455. We're going to click back to field variables, and then we're going to add an isotropic elasticity. And then over here in Young's modulus, we're going to type in 1.31, I believe. Just double check. Yep, 1.31. This is going to be e to the 10th, though. Make sure it looks all good, and then for Poisson's ratio, we're going to type in 0.29. Just 0.29. And we are all set there with what we need for Douglas fir. We can go ahead and close engineering data and then open up our geometry file and then design modeler. Alright, so I'm actually going to restart the modeling here. Don't mind the pause. But I realized I made a mistake earlier. Let's see, so we're going to go back to the XY plane. We're going to go to sketching. First thing we're going to do is actually turn on the grid, but for our major grid spacing, we're going to make this 0.25 meters. Minor steps per major. We're going to go ahead and make this 5. That way we can actually break it down kind of how we want. And now we're going to go back and select draw, and then we're going to pull up our reference geometry here on the other window and begin sketching. So now that we know that each one of these basically sets of squares is 0.25 meters, for this first one here, since we know that it is 0.2 meters, we can just go one less. So now when we go here, this is going to take us one less between, and that'll actually be the full 0.25 instead of 0.2. So we can go ahead and click here. Then we don't have any other connections up until we go to the other side, so we're going to connect back from there. But now we can kind of come over here, and in line with this 0.2, we can put this here and continue up the slope. So, and that should put us, so if we're at the edge, actually, whoops, I messed that one up. This should be to right, should be one below previous, I believe. So that gives us a height of 0.2. Yeah. Alright, so now we're going to connect up, and then we'll go to here, which gives us the full 0.25 for that next step. And then from here we go up one more time to the full 0.25. Now we're going to start to come back down, keep this kind of in line with the other, so it'll be right here, one in from the box, offset from in. And then we're going to go down again to just one, let's see, is that this line here? I was right the first time. Now we're going to come back and connect this over here. And so now we are 3 boxes away, and we want to be 4 basically. So we're going to go 1 past for this 0.2 section, and then we're going to go, that puts us 4, so 5 boxes here, gives us that full, and we're in line with this point here. So those two are all good. So we know our dimensions there are set, even though we haven't actually typed them in yet. So from this point, we're going to go ahead and connect up these 2 nodes, like so. We're going to come across, connect here, and then we can drop this down from the top. So now we're going to kind of work on the intermediary geometry in the internal part of the structure. So we're going to connect across here, and this point actually needs to be one more down, so it's in line with this section here. Do the same thing on the opposite side, and then we're going to connect across for both of these. And now we just have two more lines to draw. Boom. Alright, so now we have our geometry, so we can go back into dimensions, and we're going to start applying dimensions. So here, we know that this is 0.2. This should be 0.25. This distance from here to here should be 0.5. And then we've got 0.2 and, 0.25 and 0.2. Let's see, H5. Yep, 0.2. So now we're going to come in and we're going to do this. So this total height here should be 0.45 when it comes down to it. Oh, okay. That's going to not like that. Well, we'll see what it is just for reference. Okay, so it is 0.45, so we're good there. And what about our top to bottom height? We'll make that vertical, and that's going to give us 0.7, which, yep, so we're all good there. So yes, it is over constrained, but it is, all of our dimensions are set the way that they should. So those internal geometries we don't need to change anymore. So now we're good there. So I'm going to go ahead and click generate. And then we're going to go back to the modeling page, and we should see, yep, we have our sketch. Now we're going to go to concept, and we're going to click lines from sketches. It should select the geometry already. Go ahead and click apply. And now we're going to go up, we're going to click out of this, click generate, and we should see nice little arrows there pointing along the line. And now when we go back up to concept, we can go cross section, and it should be rectangular for this case. And our dimensions here are 5 millimeters, so 0.005 meters. Alright, so now we're going to go ahead and click generate on this. And we're going to go back to our XY plane sketch. We're going to go ahead and hit concept, and then we're going to go to lines from sketches. And now, when we apply this, oops, we need to select our Okay, so let me actually click out of that and undo, which I don't know if it will let me do. There we go. That's what we wanted to do. It just wasn't selected right. So now that we have our line body here, we can attach our cross section to that and use rectangle 1. Then click generate, and we should be good. We have our line body with a cross section. We're all set there. So now we can go ahead and close Design Modeler, and then we can open up our model. Or actually, let me double check our engineering data. Yep, got Douglas fir in there. Geometry, so now we're going to go into our model. Alright. So it says we have structural steel and Douglas fir. We're going to want to go ahead and delete the structural steel. So now we're left with only the Douglas fir. Now for our geometry, we can go in and assign this Douglas fir. So now we have our cross section across the whole body. We're going to go ahead and generate the mesh. Perfect. And now we're going to go into static structural. We're going to change our selection mode to vertex. And first thing we're going to do is we're going to apply our fixed supports at our edge cases. So insert fixed support at this vertex. Insert fixed support. It's a little hard to see. Got this vertex as well. And let's see. Alright, so those are our two support loads. Now we need to add our force loads, which are 1 kilonewton at every connection point. So I'm going to add this as one force. Insert force. And we're going to go at each of these points just by holding Control, and you can select them. Alright, so we have our 5 force loads. These are each going to be components, surface effect, and in the y direction, these are going to be negative 1,000. Oops, there we go. So that should be correct. We may have to make it 5 separate force loads, but we'll be able to see once we actually run the solution. Alright, so let's add in for the solutions a total deformation. What else are we asked for? It doesn't, so the prompt doesn't ask for anything else other than to generate an analysis report. So we're going to go ahead and stick with that. Maybe include the force reactions at the fixed support locations. Alright, let's go ahead and click solve. Make sure we don't get any new errors that we don't expect. Alright, so no errors, so we're good there. But something did not seem very happy. So let's play this animation. Okay, so it looks like just our total deformation here. It looks like the 5 millimeter square Douglas fir sections are not enough to hold up for the combined 5 kilonewtons of applied load, which is pretty expected. It's interesting to see how it buckles, but yeah, this is the second project, and thanks for watching.